Hi class, today I'm going to discuss, explain some of the uses of longitudinal designs, particularly within the context of building an effective program evaluation, and describe the specifically time-based threats to internal validity and ways that you can help minimize them. Again, this is new content. I want to make sure that it's available to students who care about it. As I mentioned in my message to students in MANA 420, program evaluation is one of my favorite aspects of this course, so it'd be a bit sad to not make it available to you. But you are under no obligation to learn this material. Since there will not be a final exam, the only things here are understanding longitudinal designs may help you to write the limitations and future directions component of the discussion in your individual project. But that's about all there is to it. So um, I'm just first in terms of what's important for the individual project. What should you be reporting in your results? This has come up. I think this is actually probably the thing that people have the most problem with when assignment 3. So that's why I talked about this quite a bit when I gave feedback on assignment 3 in class. I guess that was the last class. Anyways, so you want to include means, test statistics, and p-values. You want to discuss how the variables in your hypothesis are related. If you're working with, especially if you're working with correlation or regression design, but you can also be talking about this in terms of which mean is a larger or smaller in a t-test or an ANOVA. Type hypothesis. So is the hypothesized relationship significant, non-significant, or marginally significant? And is your hypothesis supported or not? And remember, report your exact p-value, except in the case where if it is substantial, if JASP reports this as, equal to 0 or any number substantially smaller than 0.001, then you may just report it as p less than 0.001. Oops. So again, as we've done before, this is, or as discussed with correlational or non-experimental designs, again, we are here again in the design and data collection step of the study. So longitudinal designs are really about collecting data at least 2 different time points. So, I could collect data from say the class today and next week. That would be a longitudinal design. Now again, none of the surveys that we have in this class, survey X, which are used in the assignments, and surveys A or B, which we're going to use in the individual project, none of those are longitudinal. We have collected data at exactly 1 time point per participant there. These can be used to assess differences or even change over time. And the interesting thing about a longitudinal design is it can be both. It can be experimental or non-experimental. So we can intervene or not. And they are, in general, more useful for identifying causal relationships, at least as compared to cross-sectional studies. As we talked about before, with a cross-sectional study, we always have the possibility that our independent variable is actually caused by our dependent variable. Since we didn't manipulate anything, we don't know that differences here in the independent variable are the cause of differences in the dependent variable. It could go the other way around, or there could be, that's one of the main things. So at least here, since we observe our independent variable first in a longitudinal design, we've got this. We know that whatever we observed here preceded whatever we observed there at the second time point. So again, we establish that the differences in the independent variable are temporally precedent. They occur earlier in time than what we observe in the dependent variable. Now, usually it's a good idea to measure both the independent variable and the dependent variable at the first time point, and at the second time point, or at least certainly measure the independent variable and the dependent variable at time 1 and the dependent variable at time 2. Although I would tend to argue that that second approach is what we would call a prospective design rather than a longitudinal design, but that's splitting hairs now. And again, so longitudinal designs are stronger at identifying causal precedents than the kinds of cross-sectional surveys that we've talked about or conducted in this class are. One thing about the longitudinal design is these are often used to evaluate new programs. And by programs, this could be anything. This could be a personnel selection system. It could be a training program. It could be an incentive program. Basically, anything that you do that you want to see some sort of positive change in your organization, a longitudinal design can be used for. So the Facebook research that we talked about, wow, several weeks ago now, was an example of longitudinal design. Remember, researchers have found a correlation between Facebook use and negative emotions. In particular, the more time people spend perusing their friends' Facebook pages, the more they experience feelings of jealousy, loneliness, and low self-esteem. Reverse causation was a threat in the first study discussed there, right? Because we didn't know if people were, when they were feeling these negative feelings, they went to Facebook, or if it was because they went to Facebook that they wound up feeling these negative feelings. The longitudinal study, the cross study, followed the Facebook users over 2 weeks and measured all of these things. But this way we can see it's like when you use Facebook, you then have negative feelings as opposed to having negative feelings and then using Facebook. We can see that Facebook use is temporally precedent, and therefore, while that this doesn't manipulate anything, it's still an observational or a non-experimental study. We can say that the Facebook use precedes that, so we have a stronger claim. It's at least prima facie plausible that Facebook use is the cause because it happens first, then the negative emotions happen afterwards. In terms of longitudinal designs, these are various sorts of things that we can use for program evaluation. Longitudinal designs are often used in assessing interventions that are designed to bring about positive change in the organization. So, right, we could introduce some kind of merit pay, or honestly, like a commission system, something along those lines. We could introduce some kind of exercise or mindfulness program to try to reduce employee stress. We could try to encourage our employees to recycle their trash at work. So we could do any of these sorts of things and other sorts of things as well. We could be trying to reduce accidents, and by introducing safety training, anything where we introduce the program and we want to see whether or not, basically, we want to see whether it works. So how do we go about this? So we want to establish the goals of the intervention, both proximal and distal goals. So the idea here is, in something like, again, a safety training, we may want to know that, our proximal goal might be to teach people specific safety rules and procedures. So that's a proximal goal. We want to make sure that they know those things. So you could assess that with a written or a performance test at the end of the training program. The distal goal would be actually to reduce accidents. We want to see that the accident rate goes down after the program rather than staying the same or getting worse, right? We also need to monitor the program. So this is not strictly speaking part of the research design, but we want to make sure that the program is actually being taught the way it's supposed to be. So for instance, if a safety program maybe is implemented in an extremely poorly designed online format, no irony there currently. But and therefore people are not seriously engaging with the material. Maybe they can just click through and they don't have to really do anything. There's no embedded quizzes or anything like that to make sure that they're paying attention to the material. So there you go. And we want to assess the impact. So do the outcomes happen as predicted? So again, with the safety training example, did people learn the rules and procedures at the end of the training? And then also, did accidents decrease? And again, we want to assess this using a longitudinal approach, generally speaking, because, for instance, let's see here, we want to see something along these lines. That, you know, we would measure something like accidents before the training, accident rate, perhaps, then our training and maybe even knowledge of the safety procedures, and then introduce our training program and then knowledge after, and accidents afterwards. And this way we know that if we ignored these things beforehand, all we would see is there was training, people knew stuff, and then they had a certain number of accidents. If we're measuring the accident rate first, then we now can see whether the accident rate goes down or stays the same. And the same thing, this way we can assess whether or not people just happen to know this kind of safety knowledge ahead of time, or if they actually learned it from the training program. Ideally, we'd also have a second group where we did exactly these same things. Measure this, not do the training. Measure this, and that way we'd be able to see, would give us at least a quasi-experimental design that would help us to know whether or not this was particularly useful for anyone, whether it's the program that did it. And then we have to have some decision-making ideas. So we can, based on the results of our assessment, we can recommend whether to continue and or change the program in some way. So let's say we did get a reduction in accident rate at the accident rate, but not as much as we had hoped for. Then we could try to figure out which part of the program, and this is where we could go back to some of the program monitoring. If we're observing the training, seeing how it's being delivered, how the students are interacting with it, or sorry, the trainees are interacting with it, then we can have a good idea of what sort of things we need to change in order to improve. So this is the basic idea. What I tried to draw on the board, which I'm sure is not, it's probably not showing up incredibly well here. So here we go. But the ideal longitudinal research designs are going to have this. We're going to have our pre-measure, a post-measure, and possible follow-up measures with both a treatment group and a control group. Right? Because this way we'll be able to see here, we'll see whether or not whatever we're looking to assess, accident rates, sales, whatever, what it was beforehand. So in general, what we should see is no significant mean difference between these two groups. So these should be about equal, right? These ones should be not equal, right? And it depends. Like if we're looking at accident rates, the post measure for the treatment group, we would hope to see that it's lower than the accident group, the control group. And if it was, say, like introducing merit pay or a commission system, we'd want to see the sales higher here for the treatment group and lower here for the control group. Follow-up measures, again, this is in the ideal design. Because why is this ideal? Well, because this way we can see whether or not things are stable. Like we might see here that people initially improved, whatever that means in this setting. But maybe when we look at it 6 months later here, that there's no substantial difference between the control and treatment group. essentially that the treatment group just regressed back to normal. So there was some, so the program worked, but it's not stable over time. So here we can ask some questions like, why is the control group needed? Again, this isn't an ideal design, because then we want to see that, let's say we introduce the train, like whatever the program is, but the program itself sucks, but people care about it, right? So maybe, you know, the actual material we have for our safety training is pretty bad, but people don't want to get hurt, so they learn as much as they can about safety in our context on their own. And so if we don't have a control group, we'd see is, okay, so accidents went down in our single group design. But what we'd see here is if we have a treatment and a control group, we'd be able to see, did it work for the treatment group but not for the control group? Then we have a better idea that the program is doing it. Whereas if it's if both, if neither the treatment group nor the control group change, or if both change, we'd have some evidence that it's not the treatment that's doing anything. And how can we make the treatment and control groups initially similar? Well, in an ideal space, again, we're going to be using purely random selection, or random assignment, right? So, we basically flip a coin, you go in the treatment group, flip a coin, you go in the control group, etc. That's the ideal here. A lot of times the program evaluations, we're not going to be able to do that specifically. What we'll have is maybe we're going to, like, let's say we're again introducing incentive pay and we have two different locations. We'll introduce it in one location before we introduce it in another location. So the one that gets the later introduction, they're the control group for the first one. Now again, we should do that at random. So just which location we're going to choose to do these things at, that should be random. But it's quite difficult to come up with specific ways to do this, because a lot of times we can't just randomly assign people in a real work setting. And why should we ensure that the treatment and control groups are initially as similar as possible? Well, the logic is exactly the same as in standard experimental designs. Like if there are any substantial, meaningful differences between the treatment and control group, those different at the initial instant, then whatever differences we observe could be a result of those differences in the measure that we're trying to change. So accidents, sales, whatever, are due to the differences between the groups rather than the treatment, the intervention. Why is there a need for multiple measures? Well, hopefully I've shown that. So without the pre-measure, we don't know that the program changed anything. We don't know that it did anything, so we need the pre-measure. So like, for instance, like if we think about this in a classroom setting, we basically operate under the assumption that you came into MANA 420 knowing little or nothing about research methods, right? Ideally, we would have given you some sort of a knowledge test at the beginning. So you could see, okay, people are on average pretty ignorant of research methods, and then we could compare that to assessments later on in the semester, because then we could see, like, okay, if you have learned things about it, about research methods, then it's probably because of the class. Especially if we had a control group, something equivalent to people who would be taking MANA 420, who we could give those tests to, then we could see that they didn't learn anything about research methods, for instance. And again, a follow-up measure in that case would be after we're done with the course, like maybe next year, we would quiz you, test you on research methods things and see, do you remember it? Because like this was sort of like the statistics example that I had. Like if you're not using statistics, it tends to fall out of people's heads. As a result, the follow-up measures for that are probably pretty weak. 6 months after people finish the statistics class, they've probably forgotten most of the stuff about statistics, at least anything with detail. So, and so in general, like I was pointing out, oftentimes designs are not achievable, or this ideal is not achievable. So in particular, Random assignment is often not possible at all, and a control group may not be possible. And without that control group, we have three specific threats to internal validity in the longitudinal setting that are pretty important. So history, maturation, and mortality. Now, I'll try to give a brief definition of each of these. So history effects are sort of things that happen in the world, right? So for instance, like it's possible without a control group, say, think about the Morisano study, the goal setting study that we've talked about several times. Maybe that was just a really cold winter, so people wound up spending a lot more time just stuck in their room. Like, for instance, this is a history effect that we're going through right now. Like, there's this, I mean, I can't predict which way it would go. Maybe you guys are you're just bored and therefore like going over and over like the research method stuff, and so you'll do better than other people do. You'll learn more. If we had a control group where people were still going to class face to face to compare what we're experiencing through, then we would be able to know whether or not it is a result of the online instruction here. Any differences we'd see. So history are things that happen across the board, and a control group can help us rule that out. So like in the Morisano study, the control group, if it was something like a really cold winter where everybody was staying inside and so they just decided, hey, I'm gonna study more instead of like watching Netflix or whatever, then we would see similar changes in academic achievement in the control group as in the experimental group. Maturation is something that happens inside the subjects, so you change over time as a result of any variables that are related to the outcomes. So part of this the simplest way this happens is a learning effect. And so in particular, in experimental psychology, sometimes maturation is taken advantage of. So you may do like dozens or even several hundred trials for whatever you're going to do, so that people like a lot of times maybe like you're touching a keyboard and you're supposed to, when you see a particular sort of thing, you're supposed to hit the D key, and otherwise you're supposed to hit the J key or something along those lines. And people make a lot of mistakes at that when they're first learning it. So maybe we have you do that a few dozen times so that your natural error rate goes to its lowest possible level, and that's when we start recording for the study. So maturation is just anything that might happen within the person. So learning changes. Maybe people were agitated when they started a study and then they calmed down over time. People were anxious, those sorts of things. So again, maturation is sort of study irrelevant changes that impact the outcome. So a lot of times, as we've said before, like a longitudinal study, what we're interested in is assessing change over time. Now, maturation is change over time, but it's not due to the intervention specifically. So again, the control group can help us to rule this out, right? If we see the same kinds of changes in both the control and the experimental group, again, then we have a pretty good idea that it's not the treatment that's causing any differences. And mortality is people leave the study. We should probably call this attrition, because mortality is a cause of this. So especially, I have friends who study very, very, very old people, and therefore, like some of them, like in longitudinal studies, and so therefore a non-insignificant number of them actually do die. They experience mortality between waves of the study, but that's not the only reason. People just drop out. Like if you're conducting a longitudinal study, people move and they forget to, if you're moving, there's a lot of addresses to update, and probably like some longitudinal study that you're taking part in is not going to be at the top of your memory to give them your new address, so the researchers can't find you again. People get bored, or they think it's not worth their time, and so they just stop. People forget, and so they don't show up, or say you're mailing them surveys or something and they just lose them, or forget about them, or accidentally throw them away, or something along those lines. So people wind up missing from specific waves of the study, and and in general, probably if that happens, usually what happens is people drop out altogether. So although it's possible for someone to be in, say, time 1, not time 2, and then again in time 3, typically what happens if someone's in time 1, time 2, they just drop out of time 3, time 1, drop out of time 2, and don't come back ever again. So that's what we're calling mortality, but it's really attrition. People quit the study. And again, if there's differential mortality between, if there's differences between people who stay in the study and people who drop out, if it's not random, those differences could cause any changes that we see over time. Now again, control group helps us to see this because we can look at it to see, is the mortality rate about the same between the two groups, right? Do people quit the study at about the same rate in the experimental group as in the control group? If they do, if that's the case, then whatever differences we observe are probably attributable, again, to the experiment, to the treatment. But if there are substantial differences in the mortality rate between the two groups, any changes that we see in the treatment group might be attributable to the mortality and not to the treatment that we are assessing. Again, so here's a breakdown of the longitudinal design in the Morisano study. So this is our pre-measure, right? Winter term GPA. Then the treatment intervention. And again, we've got goal setting group versus the control group. So again, pre-measures in both a treatment and a control group, and a questionnaire that assesses enthusiasm and negative emotion. These are essentially mediators within the study design, and then our winter term GPA and the number of discontinued courses. So these are our academic achievement outcomes or academic performance outcomes. So again, we have pretty close to our ideal design here. So we've got our pre-measure, treatment versus control, post-measure. Now, one thing that there's no follow-up here. It might look like it because we got this, but again, we didn't pre-measure enthusiasm or negative emotions here. That's not back here. All we have is winter term GPA. We've got the following winter's GPA and discontinued courses. So again, that's not a post-measure. So we've got no follow-up here. And this is, if you remember, this is something they discussed in the limitations or future directions, that a longer-term study might be helpful. And again, to see are the effects of goal setting persistent? Do they affect the next semester or down the line, or do they fall off? Do you maybe need a new goal setting intervention every term in order to persist? So goals of the intervention: proximal, improve the grades of the students on probation. Distal, so that's our proximal goal. Again, improve grades. The distal is reduce we want to retain students here. In the present longitudinal study, we explored the possibility that participation in a formalized personal goal-setting program might serve as an effective intervention. Program monitoring and impact assessment. The intervention group learned goal setting, and the control group did not. Again, those procedures were implemented by people on the experimental team, and therefore they presumably complied with the study protocols pretty closely. Goal setting internal validity issues. The high goal setting group had improved academic performance, higher GPA, and fewer discontinued courses, and less negative emotion. Now we got to think about, is history a possible alternative explanation? Now again, the control group helps rule that out. We would have seen something awkward there. Maturation as an alternative explanation. Maybe these students just happen to, on average, maybe when you have a particularly bad semester and you're on an academically at risk, then you just simply work harder the next semester and therefore do better. But again, we have a control group, so if that was the explanation, we'd see it. So there we go. Right? And then mortality as an alternative explanation. Well, again, if we had substantially different dropout rates between the experimental and the control group, we can at least assess how much of a risk mortality is. Again, there weren't substantial differences between the two groups in this study, so again, here we go, probably not an alternative explanation. All right. And these are pretty much the sort of examples that we've already talked about, so let's not worry about that too much. So decision making, make this type of personal goal setting exercise available to university students, right? So that's that's a recommendation that comes out of this, because it does seem to lead to higher GPA, maintenance of a full course load, and lower negative emotion. These all seem to be valuable outcomes that university professors and administrators and students themselves would want. So it seems reasonable to try to implement this kind of a program. And again, as we see here, a longer follow-up period would allow researchers to examine whether the effects continue into subsequent years, as mentioned earlier. Esther Duflo has assessed social policy using randomized controlled trials. So that's revolutionized medicine. Again, this is basically how, say, in the US, the FDA works, and basically anybody in any country that regulates the introduction of new drugs and medical treatments. You can do the same randomized controlled trial for social policy. You can put social innovation to the same rigorous scientific test that we use for drugs. And in this way, you can take the guesswork out of policy making by knowing what works, what doesn't, and at least have a pretty good idea of why things work and don't work. So here, Duflo used longitudinal experiments on malaria immunization camps. So camps with, so here's an example. So we've got camps with incentives, camps without camps without incentives, and comparisons sites. So here we go. Do free mosquito nets discourage future purchases? So when they're free, about 20% of people will then later, after that one wears out, will purchase another net at $2. Right? So 20% of people with a free net will do it, slightly higher for 65. When the initial net is provided at 65 cents, so around maybe about 24% will repurchase, whereas once we start to charge a reasonable amount, then this actually goes down. Now these two are not significantly different. You can see that this is entire within the error bars for the other one, whereas these guys are different from this. So from the looks of things, the absolute optimum appears to be a low cost net, but that there is no significant reduction from low cost to no cost for people to purchase. So therefore, if you can provide the free nets, you're not losing much. You're not losing anything statistically significant there. So, what's the best way of spending aid money to encourage children to stay in school longer? Well, look at this. We can hire an extra teacher, provide school meals, provide uniforms, scholarships, closed circuit, or I think this is closed circuit television, primary school, secondary school, iron supplements, deworming, and providing people on the information on the returns on education. So here we got, look at this. I mean, so a lot of people would tend to think that, hey, hiring an extra teacher would be the most helpful, but this is a pretty small, it increases, having extra teachers increases the less than 2 years. School meals gets you almost 3 years, uniforms, very little. This doesn't, these interventions essentially get you nothing. Iron, that's not a bad investment. You get, almost 3.5 years out of it. But this is huge. This is huge. Just crazy big. So, anyways, that would be much better if we were in person. So here we go. All the concept, again, just to spend the last few minutes here talking about the individual project. Again, it's a capstone. Remember that it's a capstone. We're trying to focus on using all of the skills in this course. So apply the core concepts from research methods, position your research in the light of existing research. So these are the peer-reviewed study. This part here, this is when I'm talking about the peer-reviewed studies here, right? So you want to be able to talk about that to position where your hypothesis testing is taking place in the perspective or context of a larger research topic. You want to make sure you're communicating the purpose of the study, the methods, results, and implications in a manner that is credible to an informed audience and to business practitioners. And again, this is what I was talking about before. Like, this is why I want people to be clear, try to avoid unnecessary jargon. If you have to use jargon or acronyms, make sure to define them the first time you use them. Don't provide unnecessary statistics lessons. Be clear. Generally, if there's a longer word and a shorter word to use, like for instance, it is very, very, very rarely better to use the word utilize rather than use. They mean the same thing, and so therefore, use the simpler, more basic word. Don't use the complicated word whenever there is an option not to. So again, reminder, you're developing 3 hypotheses and providing explanations using your background literature. You're going to use the related data, so whether either survey A or survey B, depending on your focal variable, which again, remember, you choose. Draw conclusions and make recommendations to improve the organization, to improve organizational processes. And remember, this is an individual project. I think we've covered this. So that's about all we really seriously had to say. So I'll be available for office hours today and tomorrow. Hope everything's going well and everybody's staying safe. All right, take care. Have a good one. Bye.